Hi guys, here is MH. It has been a long time since I last updated chemistry videos, but that is because there's a lot of schoolwork that I have to do recently. I'm also working on a couple of big projects that need several lab sessions to finish. Anyways, today's task is about optimizing the perchlorate synthesis covered in the last lab notes video. The problem in the old process is that both the thermal disproportionation and the extraction requires a lot of ethanol, which is very wasteful compared to the small amount of sodium perchlorate made. I changed the heating device from the alcohol stub to an electric heating furnace that I made myself using a heating wire and a potentiometer to control the power. I cranked the heat to maximum for most of the process and didn't pay attention at controlling the temperature, which could be another issue for further improvement. The thermal decomposition took around 30 minutes, during which the gas evolution of the melt gradually changes. When the sodium chlorate barely melts, the gas bubbles are appearing from the bottom of the melt and travels all the way to the top. But when the temperature is raised higher, the bubbling increases and bubbles start appearing right on the top. Finally, near the end of the process, the melt becomes uneven as solids, which are mainly sodium chloride, crashes out. This is the main stage of making perchlorates. The heating is turned off and the melt is allowed to cool. The solid cake is removed from the dish and crushed into a fine powder using a blender. The mass after the thermal disproportionation is 13 grams, and I added 100 grams of anhydrous ethanol to it. I used much more than last time because this time I'll recycle the ethanol by distillation. The mixture is boiled and filtered just like last time, and the filtrate is set for simple distillation on a hot plate. Note that the maximum temperature of the plate shouldn't be higher than 250 degrees Celsius, or the perchlorate may react violently with organics. After all the ethanol distilled off, the sodium perchlorate left in the flask is transferred into a beaker, and remaining traces of ethanol is removed. The final mass of sodium perchlorate product is 12.7 grams, which represents a yield of 44%. Still not high, but much better than last time's method. I'm not really worried about the yield, since I recycle the sodium chloride salt back into my chlorate cell, so they'll be ultimately all converted into the perchlorate. Speaking of the chlorate cell, I also modified it to be suitable for continuous production. I bought a MMO mesh anode and secured it in the cap of a plastic reagent bottle with hot glue. 2 plastic tubes made from pipettes hold the 2 titanium wire cathodes, and the small plastic cap on top of the tubes prevents salt mists from releasing out of the tube. In this way, I can seal the cell as far as possible and prevent salt creeps that destroy the connections between the electrodes and the wire. This cell would provide me with a stable source of sodium chlorate, so I can focus on optimizing the chlorate to perchlorate conversion. The ultimate results of this perchlorate process will be published around a month later. See you then.